Okay everyone, so now we are learning the storage class register or the registers variable. If we talk about the types of storage class, then we are having the four types. In the first we are having is the storage class auto, which contain automatic variable. They are also called local variable or the internal variable. The second storage class is extern, which contain external variable. They are also called global variable. Third storage class is static, which contain the static variable. Then the last one is the register storage class, which contain register variable. Now we are learning the storage class register, which contain register variable. If we talk about the storage class register or the register variable, here in this register variable are stored in the CPU registers instead of memory. To understand that, we are taking a diagram here. Let us suppose that we are having the CPU, then we are having the primary memory, then we have secondary memory. We know that secondary memory means hard drive, and today we are having is the solid state drive, which is the SSD. And these are having bulk of memory. Let's say they are having 512 GB, such type of memory is there, or maybe 1 TB. Similarly, we are having is the primary memory, just like we are having is the RAM. We know that the RAM we are having is 8 GB. How the program work? Whenever we are making a C program, first of all, that C program is stored into the hard disk. We know that just like we are saving a file, let's say ANKIT, this is the name of file. Then afterward, we are providing, let's say .c. So this is the file we are going to save. Whenever we are just running that file, first of all, that file will be coming to the primary memory. So inside the primary memory, that file is loaded. Then afterward, the CPU work with that because CPU is not connected with the hard drive. It is connected with the primary memory. So if this file is having some kind of variable, now that variable will also take memory inside the primary memory. Let's assume that in the program, we have said there is a variable and we are assuming the variable is int a. So that means this int a variable will be taking the memory. So here in the primary memory, one variable will be declared, let's say a, and that will be having the memory, let's say 301. So that variable is declared inside the primary memory, and with the help of that, CPU will work. But these are the normal variables. Now we are talking about the register variable. Adjacent to the CPU, we are having two more components. The first one is the cache, and the second one is register. Whenever we are having some repetitive task, let's say we are opening some website, their cookies are there. So that thing should be stored inside the cache memory. So from that, CPU can access. So here if you talk about that, secondary memory is the having very less speed. Then above that, we are having the primary memory, more speed. Then cache is the fastest memory. But above that, we are having is the register. Register are placed where the CPU is there. That means, let's say on the motherboard, we are having the CPU. Over there, just nearby the CPU, we are having the register. So register are with the constant contact with the CPU. So for the fastest thing, even above the cache, we are having the register. So the register data is very fast, which is required for the processing by the CPU. Now, if in our C program, which is Ankit.c into the secondary memory, let's say we are saying a variable that is int b. Now before that, if we are applying register, that means b is the register variable, and that variable will not be going into the primary memory. It will be going into the register storage, which is just nearby the CPU. So here inside the register, we are having the variable which is b. Now the important part is that here we don't have any address. Register cannot have the address for the users, means we cannot take the address of b. Just like the variable a, which is the normal variable, he is having the address, let's say 301, but the register variable don't have the address. So let's say if I am going to print and a, we know that a is the normal variable which is having the address that is 301. So that is perfectly fine. But if I am going to say and b, so here in that case there is a compiler error. So compiler will show the error in that case. To understand more, we are taking an example here. So first example, we are taking that there is a comment storage class register or the register variable. So compiler will not read this line because this is the comment. Then afterward, we are taking is the hash include, which is a preprocessive directive, stdio.h, which is the input header file for printf and scanf functions. Then afterward is the void main. Void stands for no return type. Main is the driving function. Inside that, we are saying register int a. So understand that. So inside the register of CPU, we have declared one variable. So that variable we are saying that is a. Now its address we don't have because this is the register variable. And register variable is very fast because it is very nearby the CPU. Then afterward we are saying a equal to 1. That means the value of a is initialized to 1. Then afterward we are having is the for loop. We know that the first part of for loop is the initialization. But here if we are not providing the initialization, that means it will take the already available initialization. So here this part we have skipped. Then the second part is the condition check. So condition is given that a is less than 4. Then afterward the third part we know that is the increment or decrement. So here in this program, condition is provided which is a less than 4, increment decrement. So here a plus plus is given, but initialization is not provided. That part is empty. So that means the above a equal to 1 will be considered. So when the for loop will start, the first part is already done, that is a equal to 1. So the value of a will be 1. Afterward, a less than 4. That means 1 less than 4. That is perfectly fine. So it will come inside. Then printf means printing on the screen / for the new line a. So a will be printed and %d will take the value from a, and the value of a we know that is 1. So that value 1 will be printed. Afterward, it is a loop. It will go back. So here after going back a plus plus, so the value of a will be incremented, that is 2. So inside the register we are having the value which is 2. Now afterward it will check the condition that a less than 4, perfect. Here 2 is less than 4, yes, fine. So afterward again coming down, printing on the screen / for the new line a. So a will be printed, then afterward %d will take the value from a, and the value of a is 2. So 2 will be printed. It is a loop. It will go back. So afterward a plus plus. So the value of a will be incremented. The new value of a will be 3. Now checking the condition, a less than 4. We know that 3 is less than 4. That is perfectly fine. So coming inside, now printing on the screen / for the new line a. So a will be printed. Then afterward %d will take the value from a, and the value is 3. It is a loop. It will go back again. And further a plus plus. So the value of a will be incremented, that is 4. Now afterward checking the condition that a less than 4. So 4 less than 4, condition is false. So here afterward it will come out and it will not execute the printf part. So here we can see that with the help of this loop we are keep on incrementing the value of register. So there is no problem with this program, but we are going to analyze the second example. So here we have given a comment that problem with storage class register or the register variable. Now here again we are including a header file hash include stdio.h, which is for printf and scanf functions. Then void main. This is the same program as the previous one. Everything is same. So here we are saying register int a. So that means inside the register of CPU, we have declared one variable, that is a. So one variable a is declared into the register of CPU. It is not having any address because the register variable don't have the address. We cannot access that. We don't have the permission. Here there is a change. We have not initialized its value here. If we observe the previous part, we have already initialized the value by a equal to 1. But here we have not initialized the value. We want that the registered value user should provide. So further we are moving, we are saying printf enter value of a. So here on the user screen we want to put a message that enter value of a. Then the next line we are saying scanf. That means asking from the user, taking the input %d for the integer value and a. Here we want to access the address of A, which is not possible. So here is the line because compiler is giving error. So by writing the scanf line, we want to access the address of register, which is not possible. So that means scanf line we cannot provide because register address we are not allowed to access. So whenever you are going to take the address of register variable, just like you are having the register variable int A, where we have mentioned register, anywhere if you are using and A, there compiler will give you the error. So this is the compiler error. So using the scanf statement, you are taking the address of A, wrong, compiler error. If you are assigning, let's say some variable you are having, let's say you are having a pointer, maybe star P, and you want to take the address of variable A, and A is the register variable. This is again compiler error, not possible. So address of register variable you cannot access. This is the compiler error. So the rest of the program cannot be executed. That program we know that is the same program which we have already given for and the printf as the previous program. So that program will never execute because the scanf line will not execute and will halt onto it, and compiler will show the error. So without resolving this error, we cannot execute the program. So whenever you are using the address of register variable, compiler will show you the error and you cannot execute that program. So here we have learned that register variables are stored in the CPU registers instead of memory. And to declare the variable as register variable, we use the keyword which is register. Just like in the program, we can see that here we have used the register keyword. So that means these are the register variables. Register variables we are using because registers are nearby the CPU and their access is fast than the normal memory. So if you are using the register variable in your program, then for sure your program will run faster than the other program. A register variable may be fast, or maybe your program is executing faster, but there is a limitation that we are having the limited number of registers. So we can say that the CPU registers are limited in number. That means we cannot keep on declaring the multiple variables as the CPU register. No, that is not possible. So we can say that limited variables can be declared as register variable. If you want to declare multiple variable, then that is not possible with the register variable because register memory is limited and only limited variable can be declared as the register variable. Well, let us assume that I am a user. I don't have any idea about the number of registers or registers available in my CPU. So I am declaring multiple variable and I don't have the idea. Now what will happen? So I am taking the example here. Let us suppose that I am mentioning here int, and before that I am providing the keyword that is register. Then further I am declaring multiple variables. Let's say I am saying A, B, C, D, E, F. I don't have the idea how many variables can be declared as register because I don't have the configuration of CPU. So here I have declared. Now what will happen? So how the CPU will behave? Let us assume that in my CPU there is only 3 variables can be declared. So as per the configuration there, only 3 variables will be counted as the register variable. So here we are assuming that in our CPU register there is only availability of 3 variables. That means only A, B and C, these variables can be considered. So these 3 variables will be counted as the register variable. What will happen with the rest of the variable? So these variable D, E, F will be converted to the automatic variables. Automatic variables are also called non-register variables. That means they are not the part of register. So we can say that compiler automatically convert register variable to the non-register variable once limit is reached. So here in this example we have seen that the first 3 variables are declared as the register variable. Then afterward the next 3 variables, because the register was not having the space, so CPU register was totally filled. That's why they are declared as the non-register variable. And the non-register variable we are saying to the automatic variables. So that means if CPU register space is filled, then all remaining variables will be considered as the automatic variable. But here user is not having any information. User is not aware about it. So here we can say that user cannot determine success or failure of register variable. So throughout the program, user is not aware that which are the register variable and which are the non-register variable, because user has declared all the variable as register. So user is assuming that they are the register variable, but actually some variables out of that are the automatic or non-register variable. So because the memory of register is limited, that's why only frequently accessed variable should be stored in register. So here we have learned that register variables are the variables which are stored into the CPU register instead of memory. That means they are not stored into the memory, they are stored into the CPU register. And for the register variable, we use the keyword that is register. Registers are faster than the memory. That's why your program will execute much faster. And these CPU registers are limited in number. Because of that, we have to declare only limited number of register variable. So only frequently accessed variable should be declared as the register variable. And if you are declaring more and CPU register don't have the storage, in that case, they will be converted to the automatic variable or called non-register variable. And user is not having any information. So user cannot determine that what is the success or failure of register variable. That means I have declared all the register variable. Are they really register variable? So user don't have any idea. And there is a disadvantage of storage class register or register variable, that we cannot access their address because they don't have the addresses. So just like the scanf statement, that is not possible. If you want to store the address of register variable into some pointer, that is also not possible. So their address cannot be accessed. So that is all about the storage class register or the register variable.